Off the rugged coast of New Zealand lies a stark reminder of our planet's dynamic forces. Here, White Island's underwater volcanic vents relentlessly release plumes of CO2, a process that dramatically alters the surrounding marine environment. This constant emission creates naturally acidic waters, an eerie and unsettling preview of what could become the future for vast stretches of our oceans, if current trends continue. Despite the seemingly insurmountable harshness, life tenaciously persists in these extreme conditions. Spiny damselfish, small but resilient, dart through the streams of CO2 bubbles, seemingly thriving where other species struggle to survive. But look closer, and you'll notice that the ecosystem is starkly different from a healthy, balanced reef. Many shell-building species, crucial for the reef's structure and health, are conspicuously missing, unable to withstand the corrosive effects of the acidified water. The damselfish's apparent success is undoubtedly a remarkable story of adaptation and resilience, but it is also a stark reminder of loss and simplification within the ecosystem. The reef is noticeably less diverse, less vibrant, and ultimately less resilient to further environmental changes. These volcanic seeps offer us a glimpse into evolution in action, a rapid adaptation to extreme conditions, but it comes at a significant cost. A simplified and diminished marine world, lacking the complexity and balance of a healthy ecosystem. The fish have undergone changes to survive in this altered environment, showcasing nature's adaptability, but their altered world is a mere shadow of the thriving, diverse ecosystem that once flourished here. As we observe these resilient fish navigating their challenging environment, we must confront a difficult question. What is the true and long-term cost of survival and adaptation in an increasingly acidifying ocean? White Island serves as a living, breathing experiment, a natural laboratory that offers a stark warning about the potential future of marine life in a world grappling with ocean acidification. The lesson is undeniably clear. Adaptation comes with significant trade-offs, and the future health and diversity of our oceans are undeniably at stake. Ocean acidification is driven, fundamentally, by rising atmospheric CO2 levels. These levels have been steadily increasing since the Industrial Revolution, primarily due to human activities. A significant portion of this excess CO2 is absorbed by the sea, acting as a massive carbon sink. This absorption triggers a chemical reaction, forming carbonic acid in the ocean waters. This, in turn, leads to a measurable lowering of ocean pH, making the ocean more acidic. And this is happening at a rate faster than at any time in millions of years, according to geological records. While the ocean remains alkaline overall, even seemingly small pH drops can have profound consequences, threatening the delicate balance of marine life and ecosystems. This is especially true for shell builders like corals, which are particularly vulnerable to changes in ocean chemistry, and oysters, whose shells are directly affected by the increasing acidity. Acidic waters actively dissolve the calcium carbonate that forms the very structure of shells and skeletons, fundamentally undermining entire ecosystems and their ability to thrive. Over 1 billion people directly depend on healthy oceans for their primary source of food and their economic livelihoods. As acidification disrupts the delicate balance of the marine food web, impacting everything from plankton to apex predators, it poses a significant threat to global fisheries and the seafood industry. This, in turn, endangers the well-being of countless coastal communities around the world. The ocean's silent transformation, driven by acidification, is therefore a direct and growing threat to the future of humanity. Protecting and restoring ocean chemistry is absolutely vital, not only for the survival of marine life, but also for the well-being of people everywhere. The long-term health of our oceans is inextricably linked and inseparable from our own health and survival. For fish, acidic waters mean a constant struggle to maintain internal balance. They must expend extra energy to regulate their body chemistry, leaving less for growth, reproduction, and immunity. Chronic stress weakens them, making survival harder. Acidification also disrupts fish brains, altering behavior and senses. Some lose their fear of predators or can't find their way home, fatal mistakes in the wild. Even hearing can be impaired, as seen in the Gulf toadfish. These invisible battles threaten fish survival long before we see population declines. The fight for chemical balance is a hidden frontline in the ocean's crisis. Acidic seas challenge every aspect of a fish's existence. Fish adapt to acidic waters in three ways: physiological change, behavior, and genetics. Some adjust their bodies to better expel acid, a process called plasticity. Others change behavior, seeking less acidic refuges or conserving energy. Over generations, genetic adaptation favors those best suited to the new conditions. The damselfish at White Island are living proof. Their ancestors' resilience is now encoded in their DNA. These strategies often work together, giving marine life a fighting chance. But adaptation is not guaranteed for all species. The pace of change may outstrip evolution's ability to keep up. Survival depends on both immediate flexibility and long-term genetic change. Adaptation, while essential for survival, always comes at a price. It's a delicate balancing act, a constant negotiation with the environment. Energy spent on survival, on simply staying alive in a challenging environment, inevitably means less energy available for growth and development, and ultimately for reproduction, impacting future generations. Fish, facing these pressures, may become smaller in size, a phenomenon known as dwarfing, lay fewer eggs, reducing their reproductive output, or act more boldly, taking greater risks to secure resources, traits that, while potentially beneficial in the short term, can be inherently risky in a complex and dynamic ecosystem. The damselfish's increased boldness, for example, helps them compete for limited territories and food, but it could also make them a far easier target, a more visible and tempting meal, if predators were to return to the reef. These trade-offs, these subtle shifts in behavior and physiology, ripple outwards through the entire ecosystem, fundamentally reshaping the delicate balance of predator-prey relationships and ultimately leading to a reduction in overall biodiversity. A reef that becomes dominated by only a few tolerant species, those best equipped to handle the altered conditions, is inherently less resilient to future disturbances and significantly less productive overall. For human populations, this translates directly to declining fish stocks and increasingly uncertain and unpredictable fishing catches. The very qualities that make certain fish species valuable to us, both economically and culturally, may be irrevocably lost as they struggle simply to survive in a rapidly changing world. The true cost of adaptation is ultimately paid by both the marine life itself and by the millions of people around the world who depend directly on the health and abundance of the ocean for their livelihoods and sustenance. The ocean's inherent richness, its incredible biodiversity and productivity, is being traded piece by piece for mere survival. We must ask ourselves, is this a price that we, as a global community, are truly willing to pay for the changes we are inflicting upon our oceans? The resilience of fish in acidic seas is inspiring, but it's also a warning. Nature can adapt, but only so far, and always at a cost. The simplified ecosystems at Volcanic Seeps are a future we must avoid. The solution starts with us. Reducing carbon emissions is essential. Cleaner energy, restored forests, and protected wetlands can slow acidification. Marine protected areas and ongoing research help build resilience and understanding. Every action, big or small, matters for the ocean's future. Learn, share, and support conservation efforts. Our choices today shape the world beneath the waves tomorrow. Together, we can keep our oceans vibrant, diverse, and full of life.